So how many of you know the image here? Can you tell me what kind of a sheep is this? Yes. So this is a very famous sheep called Dolly, which was born, or let's say cloned in Scotland way back in 1996. Later on, after 1996 to 2003, Dolly was found in a museum in Scotland. Unfortunately, as you can see, it passed away due to certain cloning inefficiencies. Till date, researchers are trying to find out the cause for its death. So there are a number of reasons. The first reason is there are certain cloning procedures which might have some inefficiencies. That's why researchers thought that, hey, maybe this is why there is Dolly died due to some normal effects. Till date, it is not sure why Dolly the sheep died. So I'm just going to go over some of the methods of cloning here. It's very simple. I'm just giving an example of a stormtrooper. On the left side, you can see donor stormtrooper, I can call, through which researchers will extract the DNA, and later on the extracted DNA will be injected into the recipient cell. Now this recipient cell can be from recipient trooper. So as soon as they inject the DNA into the recipient cell, we are basically reprogramming the cell. So as soon as we reprogram the cell, we do it multiple times with multiple different cells, and then there will be an embryo which will be cultured from multiple cell lines. And later on, this embryo will be inserted into a surrogate mother, so that finally we will get a cloned recipient trooper. Now, can you play the video? So this video is showing a typical method of manipulation of the cell to extract the DNA. The color what you're seeing there at the center is a DNA, let's say chromosomes. So researchers are using kind of a pipette, like a bevel pipette, poke through the cell, so which may cause some damage to the cells. So this is the process where we believe that okay, if we are damaging the cell, it may result into inefficiency during cloning processes, and that's why maybe the sheep might have died. That's one of the reasons. So for that purpose, we wanted to have a system where I can wirelessly control the cell without manually operating it. So there are a couple of reasons why we need wireless control over the cells. The major reason is that if I can somehow find a way to wirelessly control the cell, I'm not going to damage the cell. So for that purpose, I created this biochip, which is roughly the size of a quarter coin. In that, I inserted a cell, and then I could apply electromagnetic fields to rotate the single cell in two-dimensional spaces, or orient the cell. So by doing so, I'm avoiding any kind of manual contact or orientation of the cells. So, by doing this, we can only also precisely control the cell orientation, like start and stop it. So we finally provided a kind of a handy tool for the biologists so that they can use this tool for further cloning processes. So the significance of my research is unlimited, because if I can solve the puzzle of inefficiency during cloning by wirelessly controlling the cell, at present, people in Texas are also cloning woolly mammoth. It's a company called Colosseum. So, as I say, applications are limited. We can even clone any species, not just limited to sheep or with a mammoth. This can be applied to even in vitro fertilizations and a lot of other applied science applications. So yeah, by that I'd like to end the talk, and thank you so much for coming here today.